Hi, I'm Jonathan M0JSX. Thanks for joining me in another video. Now, you may remember previously in a video I discussed how the V-2000 on my chimney had failed after I put 90 watts of FM on 6 meters into it, and I thought that it had blown a capacitor. And well, today we're going to find out what actually has happened. Since the last video, I've had an installer in to swap over the V-2000, so the antenna you saw in the previous video is now up on the chimney, working very well with a nice low SWR on 6.2 and 70. 6 meters, the SWR is about 1.4 to 1 across the band, lowest about 1.1 to 1 in the middle of the band, perfectly flat on both 2 and 70. So I've now got the antenna from that was on the chimney. I've now got that here in the shack. We're going to open it up and see what has happened, and let's see if we can fix it at the same time. So let's go head over to the bench and let's see what we can see. Okay, so you join me on the bench, and I apologise for the slightly dodgy cam work and possibly the slightly poor lighting, but we have here the base of the V-2000, and what I'm going to do is I'm just going to just take out these two bolts that usually hold the sort of lower stud piece, stud mass onto the antenna. I'm just going to take them out just so we can see what we're doing. So they are out. I'll pop them off to one side. And now I'm going to remove this Allen key. Now, for complete transparency, I have already had this part, so I do know what the problem is. Now, this Allen bolt is normally glued in, so there's a whole lot of glue you kind of have to get out. Can be a bit tough, but you get in there with a fine pick or something, and you will get it out. And once you have done, you can get your Allen key. If you get the right size one anyway, you can get your Allen key in there and undo it. So I'm just going to do that. So it's that size I want. I'm just going to undo that Allen bolt, and I generally take it out all the way. I don't think you have to, but I tend to, just so I can put it off to one place that's safe, and I'm not going to lose. So I'm going to just pop it off out of shot. Then all that happens is the whole assembly can come out of the fiberglass casing. So it's just going to pull out from the bottom, and there we go. We can see the antenna. Now, I don't need to remove it all the way. I'm only going to remove it about that far because it's down here where the issue lies. Now, the base of the antenna is full of sort of an LC circuit. You can see the coil making up the inductor, and you might be able to see that that particular capacitor there doesn't look too healthy. Now, it's a little bit hard to read what the value is, but I'm going out on a limb because there's a secondary one there that says 15J. So we know it's 15 picofarads, or it's a high chance it's 15 picofarads, rated at 500 volts. Now, when I went to order some capacitors, I couldn't get the exact value, but I have been able to find some 15 picofarad rated at a kilovolt, which is obviously more than the rating of the ones that's in there. I've actually got two, because what I'm going to do is I'm actually going to replace both of those capacitors just in case. So that's what I'm going to do now. First thing I need to do is to desolder the two that are there. So I've got my soldering iron off to one side. This could be fun, trying to do it in the around the camera setup, but we'll give it a go. So I'm going to grab my my solder. Now I use leaded solder, pretty much everybody else does, which is getting a bit harder to get hold of nowadays, but you can still buy it online. Okay, my soldering iron is now up to temperature, so I'm ready to start desoldering. I am gonna do, I'll do this end first for no apparent reason other than I like the look of it. So I'm gonna pop just a tiny dab of solder just because I find it helps with flux, because the solder's got flux in it. And I'm gonna be very quick because I've got a pair of gloves on. I just want to heat up that joint there, and I will pry up on the end of the lead. Oh, it's being persistent. There we go. Lovely. And same for the other end, so I can just take that end off there, apply some heat. Okay, one set of pliers later, and I'm going to try again with this. Just going to apply a nice bit of upward pressure on there, nice bit of heat downwards, and it really does not want to go up. Come on. What I might end up doing here is just cutting it off, which would be the other option, of course. Oh, there we go. There we go. It is now off, and I've got to put a new one on. Now, with ceramic capacitors, it doesn't matter, unlike electrolytic capacitors, as to which way around you put them, which is very handy. So I'm going to do a very similar arrangement to how the first one is. Now, this the replacement is just a little bit smaller, but a little bit fatter than the one that came out. And I'm going to need a pair of snips, which is something I didn't think about. So I'm just going to grab a pair of snips. Okay, got myself my my handy cutters, because I want to try and get this as neat as possible. So give myself enough to play with. Now, I'm a fan of cutting before I solder and then holding in place with pliers. So that's what I'm going to do. This may not be very visible on camera, but I will do my best. What I'm going to do first is I'm going to tin the end of this. There's already plenty of solder there, so I don't need to worry about that too much, but I do need to just tin the end of the pliers. Now, you may be able to tell that I'm not a very clean workman, but I do tidy up after myself when I'm doing jobs like this, but I'm never very accurate or tidy when I'm in the middle of it. It's just how I do things. Right. Well, that solder ball didn't take. There we go, that one did. Let's just get rid of that. Oh, a slight mark on the table, but the matter is his. It's only an IKEA workbench, this one, and it does make actually a desk, but it's fine. It's seen a lot worse than that, I can assure you. Right, let's grab the end of that. Going to be a little bit cack-handed here, but I want to kind of get the lead like that so I can bend it around. So let's pick up some solder on my iron. Okay, let's just clean that tip. Okay, it's not a very good tip. It's not a very good iron either. There we go. Right, so let's get that onto there. Apply a nice little bit of heat. Problem is here, that whole SO239 connector is acting as a bit of a heat sink, so it's draining away all the heat I'm putting in, and the soldering iron's not that beefy to cope with that, but it will go on. And what I'll do in a minute is I will test the conductivity between the outer of the SO239 connector and that side of the capacitor. I think that's connected. I think that's taken. When I start to move it, I will know for sure. That's quite hot. Just let it cool down for a second. That end's cool, so I can lift it up there and arc it round like that. There we go. That's okay. That's going to be all the sort of same common potential anyway, so it doesn't matter if that's touching because it's touching the same part there. Right, that's good. So next thing is to bring that down, and we're soldering onto the top side of that second inductor coil. So this could be the fun part, getting that lead to sit flat against there. Okay, that's fine. I can work with that, and I can push it down. So I'm going to tin the part of the wire that's going to sit up against there. So there we go. Bit of solder applied, and now what I'm going to do is I'm going to push the wire onto the that copper winding, just like that, with the end of the pliers, apply some heat. It shouldn't take all that much heat there. There we go. That's actually done. There we go. That was a nice easy joint, solder joint, and I can just snip off the end of that wire. And now I said I was going to just check that continuity, so I'm just going to grab my multimeter. It's set to continuity up there. There you go. Right, so I'm just going to go to the end, the outer of that. There you go. That's fine. That's cool. So that's working okay. So as I say, I'm also going to replace the other 15 picofarad capacitor just because I wanted a matching set. I'm also just going to, there's a little bit of a stray end of the that capacity, so I'm just going to tighten that up as well just by snipping that off, and I'm going to replace the other one. I'm not going to do that other one on camera, that's still hot. Not going to do the other one on camera, I'll do that off camera and then come back afterwards. So there we have it, that's the second of the two capacitors replaced, and I don't think I did a bad job on that. Now so what to do is to put the antenna back together, which I'm going to do. Now it's careful not to push that in too far. We can push it out the other end, but no need. And then grabbing my Allen bolt that I put safe off to one side, I'm just going to screw that back into the same hole that it came out of, and I'm going to re-grab my Allen key that I very helpfully put away, I may remember, but there we go. So I'm just going to tighten that back up, and all that's left to do is to go back outside, reassemble the antenna, and see if it's now working. So we'll do that next. Okay, so the antenna is now up. If you've not seen what my setup is for this sort of temporary rig before, click up here for the previous video, sort of in this little series where we tested the antenna that's now up on the chimney. But exactly the same setup, more or less. I think I've got maybe slightly more coax on it this time, but in terms of the sort of SWR results, not going to make much of a difference. So we have the same MFJ259 antenna analyzer, so I'm going to flip the camera around and we'll have a look and see if replacing those two capacitors has fixed the problem. I'm fairly hopeful it is. But let's have a look. Okay, so let's start here on 6 meters. I have to say, I don't know why that light is blinking. I want to put my finger over that. It's not blinking to my naked eye, but is blinking on camera. Okay, so 51 megs, 1.7 to 1. That's certainly better than it was. Let's just sort of sweep down in frequency. Lowest point there at about 1.5 to 1. At sort of bang on 50 megs, top end of the band sort of up towards 52 megs, just over 2 to 1. So what that's telling me is, yes, the antenna is working for number one, but number two is that could easily be rectified by adjusting the length of the tuned matching section, that matching radial for 6 meters. So I'm fairly happy with that. I'm very happy to see sort of a little dip there. Yeah, look at that. So that needs to be shortened by quite a considerable margin, doesn't it? So yeah, 49.7 is where it's most resonant at just under 1.5 to 1. I'm pretty happy with that. Even as it currently is, I could rely on an internal tuner inside, say my 7300 for instance, and that would work. Wouldn't be so great with a 705 without a tuner, of course, but never mind. Cat's getting excited behind me. And the only other band that I can test on this is 2 meters. This meter doesn't do 70 sems, but let's go down to the very bottom of the band, so 144 megs. Yeah, back on 1 to 1. That's better than it was. Sweeping up the band, 145 megs. Still fairly flat, just probably 1.1 to 1 there. Sweep it up to the top end of the band at 146 megs, just smidge over 1.2 to 1. If we were to continue going up, of course, to the sort of top end of the American band at 148 megs, there you go, sort of 1.6 to 1. So I'm fairly happy with that. So those two capacitors that I replaced, one that was definitely burnt, that second one that I don't think had actually blown, but I decided to just sort of replace the matching pair. That seems to have done the trick nicely, and the antenna is now fully functioning once again. Well, there we have it. Thanks very much for joining me in this one. The antenna is working as we've seen with a nice low SWR. Needs some adjustment on that 6-meter radial just to bring it into the middle of the band, which I'm fairly confident by shortening that element that would work quite nicely, and it would then get it nice and resonant on the part of the 6-meter band that I would want it on. To be honest, with this setup, I don't know. I'd probably tune it somewhere around 50.8 megs and sort of deal with have something that's fairly uniform across most of the band. Maybe if I wanted it for FM work, I might tune it more up to sort of 51.5. But 6 meters is quite a big band. That's the thing with 6. So you've got to sort of pick the point of the band that you want. I have to say the V-2000 up on the chimney is most resonant, let's put it that way, about 1.5 to 1, sort of towards the middle of the band, and that seems to work quite nicely for things like FT8 on that. So now I'm going to pack it all up again, and this is going to become sort of a portable antenna option for me, and maybe using it with this tripod sort of out on some hilltops maybe, and see how far we can get from some hilltops. Thanks very much for watching. Until next time, 73. Bye-bye. As a very quick addendum, without the proper microphone on, I've just adjusted the length of the 6-meter radial, and my resonant point now is 51 megs at 1:1. If I just scroll down the band, at sort of the FT8, we can see 50.3, sort of around there, 1.6 to 1, and up at the FM segment, sort of 51.500. It's about the same, 50.5. Not too shabby.